It's not the same being in campus, is it? Okay, so I can see the issue with this, right? So it's unclear who the question is directed to. We'll get through this. I mean, we are all learning, so there might be some issues with interaction, but hopefully we will all learn, right? My 3-year-old is doing online classes in the next room, so if he can do it, we can do it too. So let's get started without much further ado. I'll start presenting. So present now. Yeah. Okay. Can you see my screen? Can one of you confirm? Okay, wonderful.
Yes, sir.
Okay, super. So welcome to this class. I'll make it full screen. I will also switch back and forth to admit more people, but I'm hoping that this will settle down in a few minutes. So you enter full screen. Okay, so this is your CS3100 Paradigms of Programming. And we are doing this online edition due to this COVID nonsense. Hopefully, this will come to an end pretty soon and we can meet face to face. So I am your instructor. I am K.C. Sivaramakrishnan. I have a very long name, so I go by K.C. So you can just call me K.C. Right? So no need to use my full name. Nobody uses my full name. If you see me on the street and call me Sivaramakrishnan, I won't turn. Right? So I go by K.C. So yeah, so with that, let's dive right in. So let's consider for fun this hypothetical single instruction programming language, right? This is a programming language. You can also think about this as a architecture which only has a single instruction, right? It has this sub LEQ instruction, right, which takes 3 arguments and ABC. And the semantics, the meaning of this instruction is that when you run this instruction, what it does is we consider A and B to be some pointers, right? Pointers to, say, integers. What it does is it stores into B the difference between B and A, right? The value in B and value in A. If the value in B is now less than or equal to 0, it branches to C, right? I assume you've taken C programming, so you can sort of see how this might work, right? And this is the only instruction in this programming language, right? And it might seem very strange. For simplicity, we'll also introduce another syntactic sugar, right? So this is not a primitive instruction. We are just going to drop the label C. We'll just take sub LEQ AB. We'll ignore C, where the meaning is that we are not branching anywhere. We are just branching to the next instruction, right? Really, you can sort of think about this form as just branch to the next instruction in the tree. So you might wonder, right? What can we even do with this single instruction programming language? You can write a lot of programs, right? So here is a program. Let's assume that initially the value at location Z is 0. And then you have these 3 instructions. Does anyone want to take a wild guess at what these 3 instructions might do? What it might try to achieve? Any guesses would be totally fine. Okay, no guesses. So we will just work through it, right? So this is a very simple language. We actually know what this one instruction does. So we can see, right? So initially, the value at location Z is 0. So first you do sub LEQ A comma Z, which means that you're doing star Z equals star Z minus star A. And we know that because star Z is 0 initially, now star Z, the value is minus of the value at A, right? The original location A. and we do the next instruction, which is z minus sub leq z comma b. What it does is we just apply the same rule, right? So it says star b equals star b minus star z. But we know that the value in star z now is minus star a, right? So you replace that here. And what you get is star b equals star b plus star a. And the last instruction, again, apply the same pattern. So star z equals star z minus star z, which gives you 0. So initially, star z, the value at location z was 0. Now it's 0 again, right? And in the intermediate process, b is now the value at b plus value at a. In fact, what it does, to give you a high-level term, is it does addition, right? Given two memory locations, it's adding the values in those memory locations in the second location, right? So okay, so we can do addition. We can also do other programs. So here is a program. I'm not going to explain what it's going to do, but you can see that the meaning of the instruction is so simple. You can work it out. In fact, what it does is it just does assignment. So it takes the value at location A and then stores it at the location B. You can take my word for it, right? You can work through it, and you can see that this is what it does. Interrupt me if you have questions, right? So just ask questions. I'll stop and answer. So why am I introducing this very silly language, right? There is a very important reason. This one instruction programming language or this abstract machine is as powerful as every other programming language. What do I mean by that? It's Turing complete. You can express any program in this one instruction programming language that you can write in every other programming language, right? So it's actually a very powerful notion. But if that's the case, why do we even study other programming languages? Why do we have other programming languages? What is the reason? I mean, you can basically argue that no sane person would want to write this programs in this programming language, right? You don't even want to write addition and subtraction, let alone write things like Swiggy or develop Facebook or Linux or Grand Theft Auto 5 game, right? So all of those are doable, but it would just be like gymnastics, right? Really, you have some high-level idea in mind, you want to translate it to some other you just want to express those ideas in a way that sort of captures what is going on, right? This is sort of this esoteric thing which is like puzzle solving. So we really don't want to do this programming, this particular programming language, and that's why we have many other programming languages, right? So why do we even? So let's just take this analogy, right? So if this language, single instruction programming language, is bad, why can't we just do with one single programming language? Why can't we write everything in, say, C or everything in, say, Java? Why do people even bother with other programming languages? So, and why do you have to study, right? At the end of the day, you are taking this course, and you need to ask yourself, why am I being subjected through this course while I just want to do my fancy machine learning algorithm, right? You know C, you know Python. That's sufficient for doing all the systems level work, right? And all the high level stuff. So why do we even study other programming languages? The course is about study of programming languages. So what is the reason? I think the analogy that I can provide is it's like studying a foreign language. Suppose you study French or Japanese or other language, right? What do you actually gain? You just don't learn just the language. You also learn about another culture, right? And then you pick the best aspects of their culture. You can incorporate it into your own life. You might have certain preconceptions and prejudices about others, right? And that sort of is erased by learning other foreign languages, right? And at the end of the day, even if you just want to talk in your own language, right? Even in that case, just understanding another language gives you a way of a comparative study of what your language has and doesn't, right? In that way, you understand your own language, your own mother tongue better by studying a different language, right? And the goal of this course, in my mind, is that um, the goal is that I want you to become better programmers through the study of programming languages, right? I'm not going to teach you advanced techniques in how to do Java or advanced techniques in how to do, say, Python. The course is not that, right? But the course is going to teach you certain ways of doing programming that will sort of hopefully affect the way how you write programs in other languages. Some of these statements might be very vague at this point. It will become clear, but bear with me, right? So when I say we are going to study programming languages, you might ask, okay, which programming language, right? And here, again, we can use an analogy to say, what do we mean by programming languages as a field of study? So programming languages as a field of study is to Java in the same way as linguistics is to French, right? Linguistics is the study of like various languages and features and so on, right? You're sort of dealing in the abstract. You're sort of you have abstractions that sort of capture uh, the haves and nots of various languages, and you might be able to think about certain patterns which go beyond just looking at, say, French or Hindi or Tamil, right? So you're studying these things in the abstract. In the same way, programming languages is a field where you study things more abstractly than studying individual programming languages. It sort of gives you a way to step away from a particular programming language and appreciate what the language does, right? Again, we can make this more concrete. When we say programming languages is a field, it involves a lot of things, right? We can say language design, implementation, semantics. Compilers is also part of programming languages, interpreters, runtime systems, security, reliability, testing, verification, and so on. It sits adjacent to software engineering in the family tree. But to be clear, this is not a software engineering course, right? We are going to study programming languages. And when you want to ask yourself, why am I doing this in the middle of the night trying to do this assignment? Think about linguistics, right? In the same way you study linguistics rather than just another language, we are studying programming languages rather than just another language. Okay. So when we talk about linguistics, right, I'm just trying to push this analogy a little bit further. When we talk about linguistics, there is this principle of linguistic relativity. And the principle says that the structure of the language, right, affects the speaker's worldview and cognition. So this seems abstract. So there are, I mean, in all of our languages, we can count, right? We have numbers, we can count. I can count to any number. You write down any number, I can sort of say, this number has 1,032,355, right? There are some tribal languages, right? Real languages where you can only count up to, say, 7. And then there is no word for 8 or 9 or 10 and more. They just use the word lot, right? So when you have a language that only has words up to 7, and then you're done, right? Everything is a lot. It even affects you, like you cannot express additions anymore, right? You will hit this upper limit. You cannot express subtractions. You cannot do multiplications. All of these are ruled out, right? And you cannot have advanced thought, right? So that's sort of the essence of this idea of linguistic relativity. In the same way, we can apply this to programming languages. So the way you program in a programming language actually affects programming thought. By which I mean, I might teach you some language X and Y, which has some features, right? Which another language you choose, your favorite programming language, that might be Python. Python might not have that feature, but it sort of shapes the way you think about the problem, right? Ideally, all programming languages are just tools, right? You have an idea in mind, and programming language is a way of expressing that thought. And programming languages, when we study these concepts, will shape your programming thought. At the end of the course, you will feel that you've actually gained a different perspective into how you think about problems, right? And yeah, so I think I've said everything here. And coming back to programming languages, right? Um, Alan J. Perlis is this person who was the first recipient of Turing Award, right? You know that Turing Award, which is the Nobel Prize equivalent for the computer science, right? He received it for the influence in the area of programming techniques and compiler construction. And what he said was, a language that doesn't affect the way you think about programming is not worth knowing, right? In this course, we will look at two languages, right? Um, which is hopefully quite different from what you've seen so far in your courses, right? So they sort of challenge you. They sort of unlock this part of your brain which you haven't, you didn't know existed, right? So let's just put it that way. I might be talking in hyperbole, but this is what I learned, right? So I'm just echoing those. Um, so, okay. And coming to the practical, right? The aim, we will choose two languages, right? We will choose two languages, OCaml, which is a functional programming language, and Prolog, which is a logic programming language, to teach this course. But the aim of this course is not to teach you OCaml and Prolog, right? Um, even though you will learn OCaml and Prolog in the process, it is the end goal is not teaching these two languages. I could have picked any other two languages that fit within these boxes, right? And that would serve my purpose. So when you and these languages have features that are not widely used in other languages. So it sort of shapes how you program in other languages. And the fact that languages are just tools, right? It's like picking your favorite whatever shoe or something, right? It doesn't matter. These languages come and go. So there was no Java 25 years ago, right? C# was 20 years ago. Rust is 10 years ago. I mean, it's still maturing, right? WebAssembly is this new way of programming for the web, which came 2 years ago. There might be other languages that may come next. So I would sort of advise you not to get too attached to a programming language, right? Programming language is like it's like a tool. It's like a hammer, right? When you have problems that you can solve with a hammer, use the hammer. When you want to unscrew something, don't use the hammer. Use a screwdriver, right? So you should be flexible enough to sort of not become too attached to a particular programming language. You should become an expert, right? So that's totally independent, but don't feel this need to get attached too much to a particular programming language. And in this course, what we'll do is, why am I saying this? You will learn two languages, right? And it is likely that after this course, you may never use these languages, right? So, but that shouldn't stop you from exploring the languages that we teach you in this course to the full extent, right? So don't always compare. Okay, I can do this nicely in Python. Why am I doing this in this weird way in this other language, right? That's not the point. So what do we actually teach in this course? We teach a couple of things. We will see concepts in programming languages. We will see high-level concepts in programming languages. We will also see programming paradigms. There are different ways to express the same problem, right? Some problems are expressed better in one paradigm. And we will sort of see what those paradigms are, how to identify a particular problem, and choose which paradigm to apply. Right, that is sort of what I mean by programming paradigms. And we will also see some details about language design and implementation. So the idea here is not to have you implement real compilers, right? So that is what you will study in the compilers course. the idea here is for you to appreciate how to design nice languages that have nice features, right? So we are not going to dive too much into implementations, but it's about coming up with good abstractions. Um, and we will also learn what makes a programming language, right? What is the anatomy of programming language? What is fundamental in a programming language? What is just syntactic sugar? Just like we saw in the single instruction programming language, right? So that I first showed you this instruction that took 3 operands, and I told you the second form, which only took 2 operands, is just a syntactic sugar. So essentially, there is only one, right? So you will sort of going through this course, you will identify which language features are primitive and which language features are can be implemented as library functions over those primitive features. So why this is useful? This is useful because it allows you to dive right into understanding a particular feature, right? If you can sort of explain a particular feature in terms of other primitive features, you become an expert quite quickly, right? You can sort of see through this facade, which is the syntactic sugar. You will learn some of this as we go through the course. Yeah, so you will learn new languages, right? You will learn OCaml and Prolog. So this will give you a new way to organize and describe computation, right? So and this will guide you in your exercise when you write Python in the future or JavaScript in the future, right? So um, so that's really what we are. That is also the other thing that we will do in this course. And this is one thing that we don't appreciate too much is we sort of when you start learning programming, right? It is all about the language that you pick. But if you look at the industry, new languages are being designed as we speak, right? It's actually growing a lot in the last few years. If you just take the last 10 years, right? Facebook has 2 languages that came out. So there is a language called Flow, which is a type system over JavaScript. There is a language, I mean, React is a framework, but really React is a language also. So React is this UI framework. If you were to build a UI today, it is very likely that it is written in React. Um, and Rust is this language that came from Mozilla, right? As a better replacement for C++, right? TypeScript is a better alternative for JavaScript from Microsoft. Swift is a better way of programming mobile devices from Apple. WebAssembly came from a combination of Mozilla, Microsoft, and Google, right? And Opera as well, as a better way of writing programs for the web as a replacement for JavaScript. So when you go into the industry, right, it is very likely that you will sort of encounter new languages, and this course will guide you with the ability to identify and quickly get to the root of what those new languages mean, right? You will appreciate what is the essence of a programming language. And buried in every large system, right? If you take any large systems that you work with, there is a language that is embedded in there, right? When you pick databases, there is SQL. When you pick Excel is the most widely used programming language in the world, right? So Excel is incredible, and um, Word has all these macro functions. You can write VB script, macros, formulas, etc. Emacs, the editor, has a programming language called Lisp embedded in it. Um, Anything that you do, right, in order to write shell scripts or make files to build your files or LaTeX to write your PDF, they're all programming languages. Now this whole fad with blockchains, right? All of these blockchains have smart contract languages embedded in them. So if you work on I mean, take my word for it, if you work on a large system, when you go out and do in the industry or even do research, you will design a programming language. This might not look like a new programming language. It might just look like a bunch of scripts that you put together, but it is going to be a programming language. It might just be an API even, right? And that API is also a way of you start to squint, it is also a programming language, and you are going to design it. And this course will equip you to come up with better APIs and better programming languages, better domain-specific languages, and so on. And when you are in a position of power, or when you get the freedom, right? Um, this course will sort of enable you to choose the right programming languages for the problem. I mean, remember this analogy about programming languages being tools and hammers and screws and screwdrivers and so on. So, so this course will sort of guide you, even though we don't actually delve into details. This course will sort of guide you in choosing the right programming languages for the problem. That is not dictated by what libraries are available, what standards, what your managers tell you to use, right? If I were to give you the freedom, the course will give you the ability to choose the right field. In my mind, you are going to do wonderful things in the future, right? You might do a number of things. Um, this course will give you the tools necessary for making informed choices when it comes to programming languages, right? That's the other goal. So coming to the details, right? The course syllabus itself has two languages. We will study the language called OCaml, which is a functional programming language. And we will study lambda calculus, which is sort of an abstraction of functional programming. So it's a really beautiful, very tiny language. We'll study that. We will also study logic programming using Prolog. Oops. And for imperative programming, we will see those features in OCaml, right? And if we have time, I want to show you a little bit about parallel programming also in OCaml, right? So if we have time, we'll get to that. So at this point, you might be asking, why am I asked to study this esoteric language, OCaml and Prolog, right? Are they the best choices to teach this course? Why can't this course be taught in, say, Python, right? And my response to that would be asking what is the best programming languages for this course is like asking what is the best car, what is the best shoe, right? There is no one answer to these questions, right? So let's just pick cars and shoes for the moment. There are certain cars which are fit for certain purpose, right? If you are going to win the Formula One race, there is a certain car for that. If you want to take your friends to some movie, right? You want a big car, you want to fit a lot of people and so on. So you won't take the F1 car there, right? That would just be stupid. You'll get stuck on just your garage and not get out. If you're going off-roading, you'll choose a different car. If you want to move things from your hostel to your home or something, you won't pick any of these cars, right? You will pick a car which has lots of room. So in the same way, you can think about shoes. When you want to play cricket, you choose a shoe. When you want to go to the beach, you choose a different shoe, hopefully, right? Not wear the cricket shoes. When you're going to a formal dinner, right? You want to pick your best dress shoes, right? Not the same shoe that you will wear for a beach. In the same way, you don't pick a particular programming language, right? We pick OCaml and Prolog because it gives us the ability to teach you concepts nicely. And just extending this analogy, like let's take a mechanic, right, who works on a particular, who just works, and his specialty is cars. He might have a specialty about fixing certain things in a car, right? He might be very good at fixing the transmission in the car, but he also understands how all the cars work, right? Not a particular make or model. He won't say, "Oh, if you bring a Hyundai Accent, I won't fix it. I will only work on Toyota some Camry or something," right? So he won't say that. That's not what he does, right? He might have particular favorites. He might understand a particular car very, very well, but he won't hold something personal that he won't say, "I won't work in this thing," right? And he would definitely not refuse to work on a car based on the color. That would just be a really bad decision for a mechanic, right? The analogy here is developers, right? So as developers, if you're writing programs, you sort of you might have favorites, but you can't. You need to understand all of the things, right? You need to understand different languages, and you might choose to work on one, but that doesn't mean that you'll say I won't work on this because I am being asked to write code in say Java, right? So that is not something that is very helpful. And again, extending this analogy a little bit further. So imagine a good mechanical engineer who really knows how cars work. He can actually build better ones, right? And um, he knows how to tune it. He knows how to extract the best out of it, right? The analogy here is compiler engineers and programming language specialists, right? They understand how the cars work. They might just work on a single car, right? Um, I am one of the developers of the OCaml programming language. I tend to write everything that I do in OCaml, but I also write JavaScript. I also write C, right? I also write Java whenever the situation needs it. I understand OCaml best, so I tend to lean towards it, but I'm not against any of the other languages, right? So and this is sort of you, right? When you are first learning to fix a car, or you're first building uh, like a model car, right? You're not going to build, say, the F1 car, right? You're not going to build Toyota Camry, right? Why do you want to get bogged down by features like how does this AC work, or how does this um, uh, I don't know, some remote key unlocking mechanism works? Really, you want to get to the essence, right? You want to say, what is a car? How can I understand it? How can I build it? And the languages that we've chosen, right, this OCaml and Prolog, get to this essence very nicely compared to other industrial languages. Again, this is you can sort of say this is a subjective comment, but really these languages are very good at teaching paradigms, right? Much more than Python or C or other languages. So that is why we've chosen OCaml and Prolog. So going to the details, right? When you sort of learn a programming language, you learn a bunch of things. You learn syntax, how to write language constructs. You learn semantics. What do programs even mean? What is the meaning of a particular program? You learn idioms, right? Design patterns. Given a particular language, how do you express a particular computation in the best possible way? You also learn a lot of libraries, right? Third-party library to access data structures, or um, to do a web request, and so on. And you also have lots of tools, tools like debugger, GUI, build system, and so on. So if you try to break a programming language down into these sort of 5 boxes, it makes it easy to learn, right? What are you actually mean? What do you actually mean by learning a particular programming language, right? And in this course, we are only going to focus on semantics and idioms, right? We might sort of touch upon the other things, but really, we want to concentrate on semantics, right? When I give you a program, what is the meaning of that program, right? Or a compiler or an interface, right? You will sort of learn how to reason about programs. And what do I mean by that? We tend to be very, very precise about the programs in the same way we are precise about mathematics, right? You won't say 5 plus 6, I think works like this. It can be either 11 or 10, right? That is not a statement that you would say, because mathematics tends to be very precise, and logic tends to be very precise. And in the same way, you will learn techniques where you can say, instead of saying, I feel like the conditional expressions will work like this, you'll actually know how to precisely specify how a particular language feature like conditional expressions work, right? And yeah, and why do you want to do this? In reality, much of the software development is coming up with good abstractions, right? Good APIs and good interfaces and so on. So understanding the semantics to a very deep extent will sort of guide you in designing better programs, right? That's the goal. And you will also learn a bunch of idioms, right? Idioms are, as I mentioned, common patterns of programming. So what we will do is we will look at a couple of ways of writing the same program. Perhaps some might be better than the others, right? And once you sort of see certain idioms, certain patterns, um, and you have seen the same pattern in multiple languages, you sort of see any given particular language in a better light, right? If I, for example, tell you how this is how um, function pointers work, and you see the same concept, there is a concept in OCaml called higher order functions, which are quite similar. Once you actually see higher order functions, you will understand function pointers in a better light, right? And that is what will happen. Again, I'm not going to, I won't tell you, oh, here is a pattern that we are seeing. This mirrors X and Y in Java, or X and Y in C, or X and Y in Python. We will just focus on that particular feature. But hopefully what you will see while understanding the semantics of certain features, you will sort of see that there are features in your favorite programming language which mirrors what is happening here, right? It might not mirror it exactly, but you can sort of use that vocabulary to talk about the meaning, right? How it works and what it means. So that's the other thing that we will do. So again, switching to analogy. So consider Hamlet, right? Hamlet is this famous play written by Shakespeare, and it's a beautiful work of art, right? And it has a lot of deep and eternal truths, right? It has lots of well-known sayings, and then I think you know a few of those, but I will just let you figure it out yourself. And it sort of reading Hamlet makes you a better person, because it's like reading one of those uh, any of those moral books, right? So there are lessons that you can apply to your own life, and it makes you better. And it still continues to be studied, right? Centuries later, right? It was written back in the 16th century. We still study it. I mean, that is what people do, right? But the syntax is really annoying to many. So Shakespeare in English is um, not the way you would sort of imagine writing those sentences in the same way, right? And it gets in the way all the time, even for experts, right? When you study Hamlet, there is some beauty in it, but the way of reordering these words and jumbling it sort of makes it hard to understand what is going on, right? And there are, of course, a lot of plays and adaptations of the original book Hamlet, right, with the same lessons, right? You could argue, like, I watched the movie made on Hamlet. Why do I even study Hamlet? But reading Hamlet has its own benefits, right? And of course, reading Hamlet will not get you a summer internship. The analogy that I'm trying to make here is um, think of OCaml and Prolog like Hamlet, right? So you will learn a lot of things which will sort of inform you about programming languages, but you might actually come into real practical problems with syntax, right? Um, and you can do the same thing in other languages and so on. Um, but but just like reading Hamlet has its benefits, I believe that doing programming in Prolog and learning Prolog and OCaml has its benefits, right? And libraries and tools are not our focus. We are not going to focus on libraries and tools. Again, there are throughout your career, you will keep learning new libraries and tools. It's not even worthwhile to talk about libraries and tools in this course, right? We will not even focus on that. And syntax is the most boring bit, right? People obsess over syntax all the time. Oh, we use a semicolon where we should have used something else, curly braces or some nonsense, right? In this class, we won't complain about syntax, right? If you come to me and say, "Oh, OCaml has this bad syntax," I'm not going to like even respond to that. That's the most boring bit. There is far more interesting things that are happening, and complaining about syntax is the easiest way to do bike shedding, yak shaving. I don't know whether you've heard this term. So you're sort of like focusing on unimportant things, right? We won't focus about syntax. Syntax will be weird. It will be, sometimes you might feel that there is a better way of expressing the same thing, but I think we'll just take syntax as a bitter pill, right, to learn what is going on. And in terms of course logistics, I have 10 minutes, so I'll just go through this. So the course website is available. So if you let me see if I can click on it and it will open up. Yeah, okay. The course website is here, right? And if you, yeah, so you can go and see the course website. The information is here. There is not much here. I'll start filling the schedule and assignments. There's a lot of resources here, right, for how to reading, right, recommended reading and so on. One thing I will highly recommend in this course is following this Cornell CS3100 book for OCaml, right? It's an incredible book. It is written in a very easy manner, right? And it's freely available here. And the lectures will not closely follow what the way the book is organized, but I expect you to read this book, right? I won't ask questions that are only in the book but not taught by me. That won't ever happen. But you are expected to read the chapters that I point to, right? So if you just um, go with what I taught in the course, what I taught in the lectures, you will miss certain things, right? Of course, I'm going to ask questions on topics that I've taught only in the lectures, but you're not going to, I'll add a little spin on it. But if you haven't sat and thought about those questions in a different way, you will sort of, you might lose points, right? This is my recommendation, right? I don't care if you read the real world OCaml, but do follow at least I'll point to specific chapters, right? You just, and those are very small chapters. So please do read those chapters, right? We are not going to have quizzes. We are just going to have final exam. So don't wait until the last final exam to read the entire book. That's not going to work. If I point to certain reading material, do try to read it. It's quite important that you do. Okay. Yeah, let me go back to this thing. Okay. So it's here. So, okay. And there is a course Slack. I think some of you have already joined. Do join Slack. It's much more interactive. So if you have a question, I can quickly answer to that. Moodle is very bad at formatting code, and you can, we are not going to be able to meet in person for resolving your doubts. So just ask a question and I can quickly respond to it. And it's also a nice way to like help your fellow students with questions, right? So Slack is very nice for them. So I usually hang out on Slack, but I highly recommend joining Slack. So lectures are delivered through this interactive Jupyter notebook. I don't know how many of you have used Jupyter. If you've done any sort of Python and data science things, you would have used Jupyter. So the way this course is going to be delivered is just Jupyter notebooks, right? And I use it for lectures. I use it for executing code in place, right? And I also use it for the assignments. So the way assignments are given is you are given a Jupyter notebook. You just, there are boxes where you fill in the solutions. You can run the Jupyter notebook to check on the open test cases, right? And there are some closed test cases which I only have, but you can actually interactively program in the Jupyter notebook and you will submit your Jupyter notebook. We will go through this slowly, but everything is going to be delivered through Jupyter notebook. And there are instructions on the course website how to work with Jupyter notebooks. I highly recommend interactively exploring the Jupyter notebook, right? That is the way you learn. Don't convert the Jupyter notebook to PDF and then read it. That is not going to give you the experience. This is paradigms of programming. We are not just going to study these things in abstract, right? It's like a toy, right? So when I give you a toy, you can describe that the toy works like this, works like that, and from a distance. But really, the way you want to understand the toy is play with it, try to take it apart, break it, put it back again, and so on, right? Unless you actually play with your hands, you're not going to learn the concept. So we don't have labs, right, in this course, but um, this is going to help you practice a lot. You don't have to write arbitrary programs, just practice what is taught in class, right? So, and this Jupyter Notebook setup is very easy for that. And this is the grading pattern that I have. For NSEM, we'll have 50%. For programming assignments, we have 7 assignments. Each of these assignments should take you like 2 or 3 hours, right? They are not going to take you a lot of time. If you are following the lectures, they are not going to be very difficult, right? They will get progressively a little bit more complicated, but they are not going to take like 2 full days of sitting and solving the assignment, right? So these are going to be short ones. There are going to be enough examples to guide you through solving the assignments, and the interactive notebook is quite useful for that. And I don't want to load the course. I mean, we have a very weird situation where we don't have quizzes, so I don't want to award all of the scores to the NSEM, which will be very yeah, that's not going to work out. I personally wouldn't want it. So I'm going to have assignments. I'm hoping that you will have the ability to run the notebooks. If not, do email me, and then we will make sure that you set up the notebook and you have some way of doing the assignments, right? And if you have problems, you should write to me. You should use the email me, right? That's the best way to interact through this. And I mean, adding this, it's not coming to 100%. So 1% for class participation. Just show up. There is no attendance. Just show up in class. Try to answer questions. Interact, right? Do something to get that 1%. So it's not going to be hard, but be interactive. Ask questions. Right? So that's really what I'm looking for in that 1%. And plagiarism, I'm going to be very strict on plagiarism, right? I don't. This is going to be a programming course. Like 50% is going to be programming. These are going to be very easy programming assignments, right? If you plagiarize on it, you are going to get 0, right? For that assignment. If I find you repeatedly plagiarizing, you're going to get a U grade. I've enforced this in the previous year, so I'm not going to be going to shy away from enforcing this again, right? This is the last time I'm mentioning this, right? If you come to me and say, oh, can you relax the rules for me? I'm not, right? I'm going to follow this very, very strictly. And we use multiple plagiarism detection software. We have all the assignments from the previous year in order to check. So make sure you try it out, right? And these are not hard. So if you have a question, if you don't understand, rather than plagiarizing, just come talk to me, right? And we will figure out, also the TAs, right? They will know how to teach you what's going on. But don't plagiarize. That's my, and I'm not going to relax on this. I think, let me see how many slides I have. I think we are out of time. I don't want to, last slide. Okay. So again, so we will use OCaml Prolog in this course. All of the material is provided through Jupyter Notebooks, right? There is a Docker image that is available. If you don't understand what is Jupyter, what is Docker and everything, I will have a class where I explain how I set this up, right? It's very easy, but I think if I show you how this works, it'll be sort of easy for you as well to appreciate that it is easy. I'll do that on Friday, right? And you can install it locally, but I don't recommend doing that. It's a bit of a mess. this local installation of OCaml and Prolog. But you don't need advanced knowledge of Docker or Jupyter Notebooks. It should just be plain and easy. So hopefully we will sort it out. We'll make sure that everyone is sorted, right? We won't let anyone down before giving the assignments. We'll make sure that all of you have some setup where you can practice course and submit assignments. Okay. So I'll stop here, and we will get into more details in the next class. Any questions? No questions? Okay, so I will stop recording. Okay, so I see some messages I haven't actually seen. Sorry, I didn't see any of the messages, right? So I was in my full screen mode. I'll try to see how I can get the messages. I'll try to figure it out. Okay, so I'll see you tomorrow. Thanks, everyone.